So now we'll do part 2 because we've done part 1, and you should always do part 2 after part 1 when you're a scientist, because scientists are of course methodical and orderly and logical. And in part 2 we're taking the now known permanganate solution. All of part 1 was to enable us to determine the concentration of my potassium permanganate solution. You might have not done the calculations yet, but you at least have the data to do those calculations. So we know the permanganate solution concentration, and we're going to use that to determine the concentration of the unknown oxalate solution. And the actual experimental process is essentially the same. We take a solution that has the oxalate in there. In part 1, we knew stuff about that oxalate solution. Here we don't know stuff about it, so it's unknown. And we're going to add some water. We're going to add some sulfuric acid, mix by swirling, repeat the titration process as described above. That includes the heating and so forth, and record the total volume of potassium permanganate solution added. So very, very much similar experimental details. I am, however, going to focus, before I move on the first 4 sort of wordy things of this. Pipette. Well, a pipette looks like this. It's a long glass tube that has the graduations. Okay, this green thing up here is to enable me to suck up the solution that I can suck up by sticking the point of the pipette in a liquid. Now, the numbers on this are somewhat interesting. You can't see them very closely here, so I've magnified it up here. The top graduation is 0. It starts down here at 9. So if you've sucked up enough liquid to get to that, to the 9 mark, that means that you've sucked up 1 cubic centimeter, because the whole thing can take 10, but you're down to the 9, and then 8, 7, 6, and so on, all the way up to the top part here, 0. So if I want to use this 10 cubic centimeter pipette to get 10 cubic centimeters of the solution, I suck up the solution so that it goes up to the 0 level. In other words, there's 0 cubic centimeters left to get up to 10. Here there would be 1 cubic centimeter left to get up to 10, so if I'd filled it to this level, there would be 9 cubic centimeters of the solution left in there. Okay, now the idea of using a pipette at this stage versus using the graduated cylinders that I use for the other volumes is something that again features in the post-lab questions. So I want you to know exactly the context that we're talking about there. So anyway, did all this, and now let's look at the data. So each one of my 7 trials, I took 10 cubic centimeters of the unknown oxalate solution. Okay, so unlike for part 1, I'm starting off with the same amount each time. And then I measure how much potassium permanganate I need to add to this. And you can see that there's a range from 15.2 up to 15.4, but these are all pretty nice and similar. So one would certainly say that the C word concordant applies to all of these data. So now what you need to do is you need to take the known concentration of the permanganate, and once you know the known concentration of the permanganate, you can use that with the volume to get the moles of the permanganate. From the moles of the permanganate, you can determine how many moles of oxalate that would react with, and once you know moles of oxalate, well then you can combine that with the volume to get the concentration of the oxalate solution.